All right, I'm looking at 2.2, part of the review for advanced math, looking at number 86. And they're asked to graph this thing. They basically want the zeros. They want some sufficient plotting. That's basically what we call those kind of turnaround points. So let's go through this. So first is I'm going to look at end behavior. So it's got an even coefficient, an even power and a positive coefficient. So that means they both are going to end up. Okay, that's for my end behavior. Okay. Now I need to find some zeros. So I'm going to take out a GCF. I'm going to factor this thing, set it equal to 0. And I'm going to say x squared minus 4. So I'm going to get, if I can factor some more, x times x minus 2, x plus 2. That's the difference of squares. So this tells me my roots are 0, 0, x equals 2, and x equals negative 2. And it matters that I have these two zeros, right? Because that tells me the multiplicity of 2, and we're going to bounce and not actually go through the x-intercept there. So I'm gonna go ahead and plot that stuff for now. Then I'm gonna come back here. So we got 1, 2, 3, 1, 2, and 3. So I'm plotting at, I got an x-intercept at 0. I got an x-intercept at positive 2, and I got an x-intercept at negative 2. So now what I need to do is I need to plug in some points to determine how they turn around. So just keep it in mind here, they both end up here. Okay, so that means I basically got to cross here, turn around, I bounce because I have two zeros, I bounce here and come back out. So I just got to figure out how far basically down I need to go is all I really need to figure out here. So what I'm going to go ahead and do here is plug in some points. I'll just plug in 1 and negative 1. All right, those are about right in the middle. They actually are in the middle. So I'm going to come down here and give myself a little bit of room and plug those into the original function. So that is, I'm going to do g of 1, 1 to the 4th minus 4 times 1 squared. And I'm going to do g of negative 1. And because this is an even function, they're actually going to be the same, it looks like. But okay. So this is going to be 1 minus 4. This is a negative base to an even power, so that's going to be the same. So they're both negative 3. Okay. So 1, 2, 3. So they go down about right here and right here. So if I wanted to sketch this thing, I'm basically coming here, I'm turning around, and I'm bouncing at 0, coming back down, turning around, and ending up. Okay. And there is a sketch of the function. Okay. Jumping to section 2.3. Looking at number 14. And number 14 says divide. And they're asking me to divide 2x to the 3rd minus 3x squared minus 50x plus 75 divided by, kind of running out of room here, 2x minus 3. Okay. So the one thing we got to do is make sure every power is represented in both terms here. So 3, 2, 1, 0, and 1, 0, so we're good to go. So I'm going to set this up for just like long division. Okay. And I'm going to go ahead and say 2x to the 3rd minus 3x squared minus 50x plus 75. Okay, see if I can change colors here. So to do this, remember, I got to match this one to that one. So this one basically needs an x squared. Put it over the same power. Okay, so multiply by x squared. Then I'm going to distribute that to everything here. 2x to the 3rd minus 3x squared. Okay. Then I'm going to do the opposite. Subtract it. So this cross out, this actually comes out to 0. I'm going to leave the x squared in there just to kind of keep the place. Bring down the 50. And what do I have to multiply here? It's going to be plus 0. Okay, so we get 0 x times negative 0x again, or positive, however you want to think of it. It doesn't really matter. I'm just kind of keeping the place. So bring down my negative 50x, bring down my 75, and what do I have to multiply by here to make these two match? It looks like a negative 25. Okay, a negative 25, and that's going to be negative 50x plus 75. Subtract them, do the opposites, and this comes out 0. So this looks kind of weird, so it actually is just going to be this. Okay, no remainder. Okay, looking at number 47. Now we're going to use synthetic division. So for 47, setting it up, let me write what the actual function is for 47. X to the third minus 7x plus 6. So remember, I got to make sure every power is represented and use the coefficient. So this coefficient is a 1. I need a 0 because I need an x squared. Okay, so remember, you bring down the first one. It's always multiply, add, multiply, add, multiply, add. So multiply these two, and then add them. Multiply them, then add them, and then multiply them again and add them. So that actually divided it out evenly as well. So if I did divide by this root of 2, it would actually equal x squared plus 2x minus 3. It brings it down a power. Right? It was at 3, now it's at 2. Jumping to number 87. So for number 87, I'm going to look, they want me to find all the possible zeros. Okay. So here's the function they're giving me. Okay. So what I'm going to do here first, I think, to make my life a little bit easier, is I'm going to factor out an x. It's the third minus 14x minus 4. Okay, so now I got one easy 0, right? Because I want to set this equal to 0. So I got 1 right there. So for this one, I'm going to have to use my rational zeros test. And so I got to list all the factors of the last term, and then I got to list all the factors of the first term, and then put them on top of each other, right? So the ones on the back go on top. So I got to use all these numbers. So it's plus or minus 1, plus or minus 2, plus or minus 4, all over plus or minus 1 and plus or minus 3. Okay. So then I find all my options here, and if I do that, it looks like it's pretty much going to be plus or minus 1, plus or minus 2, and then plus or minus 4, and all of those go over plus or minus 1, plus or minus 1, and then plus or minus 1. Now I do that again, but I put them over the 3's. So I'm going to say, plus or minus 1 all over plus or minus 3, plus or minus 2 over plus or minus 3, and plus or minus 4 over plus or minus 3. Okay. So these reduce. I'm just going to list these as this reduces to plus or minus 1, plus or minus 2, plus or minus 4, plus or minus a third, plus or minus 2/3, and plus or minus 4/3. Okay, so those are all my options. There's a lot there. Okay, and I'm going to use synthetic division and try to find them. Okay, so start with the easiest ones. Hopefully you get lucky. Okay, so I'm going to go with 1. I'm going to go to another piece of paper here. So the one I'm dealing with is the one after I factored out an x. Okay. So I'm going to say 3, 0, negative 14, negative 4. And then this is, I'm going to try a 1. So I'm going to bring this down. I'm going to add. And that did not work. Okay, I'm going to try negative 1. And I'm going to try 3, 0, negative 14, negative 4. Bring it down. Negative 3, 3, negative 11. 11 again, didn't work. Okay, so I'm going to go ahead and try negative 2. So bring that down, negative 6, positive 12, negative 2, and then positive 4. So that worked. All right. So that's good. Now here's what I got. I can keep guessing. Okay, I got one root. And if you look back at the original one, there's 3 of them, right? So I could guess more. But what I have here now is everything dropped to power. So the polynomial that I have is, you know, x plus 2, that's from this, times 3x squared minus 6x minus 2. So this is a quadratic. I'm just going to plug this in the quadratic formula and save myself some guessing. So I'm going to go ahead and just say, all right, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then I'm looking at 6 plus or minus the square root of 36 minus 24, looks like. 24, 12 times 2, no, positive 24, all over 6. On to the next page. 6 plus or minus the square root of 36 plus 24. All over 6. And I can take a 4 out of that 60, right? So this is going to reduce to plus or minus, you know, root 4 times root 15 all over 6. And that reduces to 6 plus or minus 2 root 15 over 6. And I can only reduce if I take it out of both of these terms. So I can take a 2 out of both of those. So it leaves me with, so I cross that out, leaves me with a 3 here and a 3 there. So I'm looking at 3 plus or minus root 15 over 3. So my roots were negative 2 and 3 plus or minus the square root of 15 over 3.